Okay, so next example. Here we say an open top box is to be made by cutting small congruent square from the corner of 12 times 12 sheet of the tin and bend up the side. So what's mean by that? You have 12 times 12, so means you have a square, and then they cut off the small congruent at the corner and they bend up to be an open top box. Maksudnya kotak yang atas tu buka. Okay, so you bend up. You can bend out this side, you bend out this side, you bend out this side, you bend out this side, so you can get a box here. So an open top box. So dia potong segi empat kat tepi sini. So you can see what's your constant here for sure. 12 cm for your length and your width, they are constant. This thin sheet must be, this open top box must be made of 12 times 12 thin sheet. So how large of the square to be cut? So your variable here means the unknown. We are not sure or how much your square to be cut, so that you can adjust to be having maximum volume. Alright, so therefore your variable here will be your x. This is your side of the square. And then the quantity that you want to maximize here will be your volume. So your first step is going to identify all the quantities that you want. Okay, this is constant 12, length and width, variable, your square, and then the quantity you want to maximum here is volume. So second step, once you say you want to maximize your volume, means your formula must be start with your volume. So how to obtain this volume of this open top box? When I cut this square, means this side will be leaving 12 minus 2x, right? When I cut this side, this one x, this one x, so means this side will be having 12 minus 2x. And then when you fold up, means your height of this box will be only x. So your volume of this open top box will be 12 minus 2x, and then 12 minus 2x for your length and width, and the height of the box is x. So second step is obtain our equation in single variables. So obtain our volume equation in single variable. Yes, it is in terms of x only, one variable only. So means that these equations are ready to differentiate and verify the critical number. Alright, so we expand this formula for us easier to differentiate. So expand this 144 times x, then this one minus 48x at the back, x squared, then 2 times 2 will become positive 4x squared times x cubed. So this is your formula in single variable. Step number 3 is start to find out critical number. So we're going to differentiate, find the first derivative dv, differentiate v respect to x. And then let this first derivative equals to 0. So this is a quadratic equation. And we notice that this quadratic equation can be simplified. Divide by 12. So here we have our critical number. So we have two critical numbers here, which is x equals to 2 and x equals to 6. So the next step is going to find out second derivative test to verify which one is maximum. Which critical number gives us a situation of maximum. So come from our first derivative, we proceed differentiate v respect to x. For second derivative, it gives you negative 96 plus 24x. So we're going to test these two critical numbers. When x equals to 2, so what's your second derivative test? You have to show out your working because second derivative test is depends on calculation. So it gives you a value of negative 48. Once you get your result, you have to justify your answer. Negative less than 0, so it will be concave downward. So this is the case of maximum. Another, when x equals to 6, substitute into our second derivative. So it gives you positive. So positive concave upward, this is minimum. So what we want here is maximum volume. So we managed to verify critical number which give you maximum situation, which is equals to 2. So this is the result, maximum. So we can take x equals to 2 to maximize everything. So what's the thing that asks us to do? Number 5, last step, we answer the questions. We answer the questions. So look at the question. They say how large the x should be, how large the square should be cut so that it will have maximum volume. So means we have to cut the side of the square is 2 cm times 2 cm in order to build up a maximum volume of open top box.